Okay, so in this video, what we're going to be looking at is the core section, some of the questions from the core section of 2018 Further Maths Exam 1. Okay, so this is data analysis. So we're looking at question 1 and 2. We've got a dot plot. So it's got 25 bits of data for difference in travel time. Okay, so difference in travel time between the morning peak and the evening peak. Okay, so question 1, percentage of days when there was 5 minutes difference in travel time between that morning and evening peak. So what we're looking at is saying it's minus 5, 0. What we're after is actually this one here. Okay, so I've got 1, 2, 3, 4, 5. I've got 5 days where there was a 5 minutes difference in that time. And so we want as a percentage. So it's going to be 5 divided by 25 because there's 25 journeys, and we times that by 100 to give us our percentage, and from that we'll get 20%. Okay, so that would be question C is the answer. Question 2, the median difference in travel time is what? Okay, so when we're looking at this, median, remember, is the middle number, and as a way, what we need to find is the position of that middle number. So numbers, we've got 25 bits of data, and an easy way we can do it is n plus 1 over 2. That equals, so 25 plus 1 will give you 26. 26 divided by 2, I might have said multiple. That will give you position 13. You can also do that if you know how to look from either side, but that's an easy way that gives you that number. So what we need is position 13. Let's change color. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's going to be in 1, 2, 3. That's going to be the difference in travel time. The median number is 3. So the answer is going to be A in this case. Okay, so let's go on to question 3 to 5. So pulse rates of a population of U12 students is approximately normally distributed. Okay, this is important to remember this one. Approximately normally distributed with a mean of 69 beats per minute and a standard deviation of 4 beats per minute. So when you see something that says this has a mean, has a standard deviation in it, generally what you're going to find is that the question is going to be looking at probably on Z-scores, which you'll see a potential question later on, or we've got a Z-score here and here, but usually is looking at that 68, 95, 99.7 rule. And so to help with that, I've just got a little graphic that I've just moved into the frame now. So in this first question though, what we're asked is, we've got a student selected at random from this population has a standardized pulse rate of Z equals minus 2.5. So how do we get his actual pulse rate? In a question like this, you've been given enough information to do it. So you've been given the standard deviation, you've been given the mean and the Z score, okay? And you can use this equation here. So Z equals X minus, so that's your value, that's actually the one you want to have, minus X bar over S, the standard deviation. So what you're going to be putting into your calculator is you're going to be solving, in this case, for X. All right, so effectively you're going to be going minus 2.5 equals X minus, you've been told that the mean was 69, so 69 divided by the standard deviation of 4. Now, you can transpose this or use, and my suggestion here would be use solve, put that in solve, go solve, put the brackets around. So you're going to have solve, then comma X, and solve it like that, okay? And that'll solve for X for you. And when you do that, your answer will be, so X will be 59, okay? And that is answer A. All right, so question 4. Another student selected at random from this population has a standardized pulse rate of Z equals minus 1. the percentage of students in his population with a pulse rate greater than his student is closest to what? So, in this case here, what you need to look at is the position of z equals -1 on this graph. Okay, so this is on this graph here. I'm going to get rid of that now because I don't want it to spoil. So z equals 1 is here. So that corresponds to 1 standard deviation in the negative direction away from the mean. But what does it, so we've got a percentage, okay? What the percentage mean is we're after that distance there, like that percentage, that distance, that percentage there. So it's basically going to be 34 plus 34 plus 13.5 plus 2.35 plus 0.15. When you add those up, this area here is 84%. So that means the answer is E. Okay. Let's go to question 5. Okay. Keep that in there. Question 5. A sample of 200 students was selected at random from this population. The number of these students with a pulse rate of less than 61 beats per minute or greater than 73 beats per minute is closest to. So what we need to look at here is on this. So let's have a look at this. So our mean, remember, is 69. Okay. We go 4 each way. So 69 minus 4 is going to be 65. Okay. And that's going to be 61. If we go up the other way, we're going to get 73 and 77. Okay. All right. And so what we're looking at then is percentages of pulse rate of less than 61. So we're after that part. So that's going to be 2.5%. And what the other one was 73. So 73 is this part here. So that's going to be 13.5 plus 2.5. So 13.5 plus 2.5 is 16. So that's going to be 16%. Okay. And then what we want to do from that, and we've got that 16 and we've got the 2.5 from the other end. So that basically our two ends. Let's actually just do it in a different color. So what we're looking at it is this part here and this part here. Those are the two areas we're looking at, and that's 18.5%. So that's going to be here. So we've got 18.5% of 200. Okay. And when we do that, we will get, so the way you can do that is just go 18.5 divided by 100, because that'll give you into decimal, because that's what you need to do, times 200, because there's 200 students, and that will give you 37%. 37%. Sorry about that. That'll give you 37 who meet those criteria. Okay, so that means our answer is B. Okay, so I'm going to finish this part off here for those first 5 questions. Okay, thank you.